So now let's do the construction of the right angle triangle. I will define two sliders, one for the base and another one for the height. And doing that, I will be able to make a dynamic construction. So let's do that. First of all, I will define the base, that I will call it C, with a minimum value of 1, because a segment cannot take negative values, and a maximum value, for example, of 9. I choose a random number. Now let's define the height. We will see one interesting thing that it will happen now. So defining the height, that I will call it h, the minimum value that a segment can take is 1, and the maximum value for a right angle triangle, and we have to remember the properties, that it's the base divided by 2. So the base is 1, C, but here takes the value 1, so I will say C divided by 2. Now let's see what happens. The new slider H doesn't appear in our screen. So we go to the algebra window, and here we see that H is undefined. Why? Let's go to the properties of the object. The minimum value that H can take is 1, and the maximum is C divided by 2. Now C here is 1. So we are not doing a coherent construction, because the minimum is 1 and the maximum is 1 divided by 2, that is 0.5. So for that reason this construction is wrong. We should change the value of C and say, for example, that C has a minimum value of 2.1, for example. Now we have our two sliders defined. As you see here. Now let's move to the construction of the triangle, once we have defined the sliders. Remember that first of all we have to define the sliders, because if not, we cannot make the constructions. So I will create a random point, for example in 1, 1. I will define it here in the algebra window, 1, 1. That will be the vertex of the triangle. And now I will make a segment with the given length. That will be the base of the triangle, so it will take the length of C. Now, when the value of C changes, the size of the base of the triangle changes as well. So now let's go to the construction of the height of the triangle. But first of all we have to remember about Thales. So for constructing a right angle, we need a semicircular arc, that I will do it from A to B. So all the points of one vertex of the triangle will be around this conic object D. Okay, now let's make the construction of the height. We have so many different ways to do it, lots of ways, but I will explain the one that is, in my opinion, more comfortable and more coherent. So we will define a circle with center and radius, that the radius of this circle will be h. So now I have created a circle with a dynamic radius. The height is defined by the perpendicular line of this of A, a perpendicular line of A that goes through B. And now if I make the intersection between this line B and the circle E, between B, we will have these 2 points, D and C. The points, as you see, move, so we have defined it our height, that is the length of the segment DB. So here DB takes the value of 2, and now for example it takes the value of 1.4. But we want to have the height of our rectangle triangle in this arc. So I have to make the construction of a parallel line that goes through D and it's parallel to A. And now if I make the intersection between this conic object D and the parallel line I created, we will have the point F. That this point F is the height of our right angle triangle or rectangle triangle in this arc. Now as you see, I will make the demonstration how it works. So for example, when H is smaller, the value of F goes down, and when C goes up, and it changes as well, as you see here. So now, for working more comfortable, we can make the objects invisible as if you remember. So I just have to go here to these circles and make the lines that I don't want invisible, just clicking on the circle, as I did with this line F. So I will do the same with B. Or I can go to the object in the graphics screen, the graphics window, go to the right button, and then click this condition of show object. So now the object will disappear. I will do this operation with all the points and objects I don't want. So now the screen is more clear, and as you see, it has not lost the properties that I defined it before. Just I made these objects invisible. Now that I defined these 3 vertex, I will make the construction of the triangle. So I will go here to the definition of polygon, and I will select the 3 vertex, A, F, B, and again A. Now as you see, we have our polygon, that it's a triangle. Note that here in the algebra window and Geogebra detects that it's a triangle. The polygon, that is the one I defined, it's a triangle. And I don't need these auxiliary lines I used, so I will make them invisible again. Show object, and this segment A, that it's here, I will make it invisible as well. Remember, you can do it from here or from this circle. So now I have my triangle constructed, and it works. Dynamic. So as I change the values of the base and the height, it changes. Now let's customize the triangle. So if I want to change this point, because this one is A, B, so this one must be C, I go to the properties of the object, and here I can change the name of the object, but here I will change the definition. So if I write C, it will create another point C, but this point C will be C1. Let's see that. I create the point C, I change it for C, and now, as you see, as we define it another point called C, the one I define now and with the same name stays with C, but the one I defined before changes. For avoiding this, what I will do is to go back. I will undo this, what I do. So now we have our point C, that it's, let's see which point it's this one, it's this one from here. As I don't want to change it, we'll make it invisible again, and I will go to the properties of the point F, this one, and in caption I will write C. Remember that caption, and now when I show the label of caption, it will show what you write here. You can write whatever you want, but now I will write C. And I will do the same with the other segments from here, with the other sizes of the triangle. So let's do this with A1, which is this size from here, so it must be equal to 1, to A, sorry. Caption A, and show label caption. Now, this one from here will be B, and the other one, F, will be C. So now we have defined our right angle triangle with a current names. I will customize as well the slider with the object, so that it will be easier to understand. So let's do that. I go to the definition of this segment, to the properties of this segment, and now here in color I can choose the color I want. So for example, I will select blue, and I will make the line bigger, for example at this size. And here in the slider I will do the same. I will change it to blue. So now for the user it's easy to understand that C is the base. And I will make the same for the height. But first of all I have to define this segment. So for doing this I will make an intersection, a perpendicular line between C that is perpendicular to C and cuts in C, in the point C, and now I will make the intersection between this line, this perpendicular line I created, and the segment. So here we have G, this point G, and now I will make the segment from G to C. As I don't need this perpendicular line I created before, I will make it invisible, and as well with the point G. So now here we have our segment that represents the height, so I will call it H. Remember again the caption here, H, and show caption in the label. So now it's H, and I will give, for example, a green color to this height, and I will make the lines bigger, size 7, as I did before with the base. So here this slider will be green as well. Another user, for the user it's easier to see that H is the height, because both are green, it's the slider, and when you move C it will change the base. Now I will write the formula of the area of the triangle. So I create a text and I use LaTeX, so it's easy for the fractions and this kind of signs. So I say that the area of the triangle is equal. Now I go here to the LaTeX formula and I select the fractions. It's the base, which is C in our case, multiplied per H, which is the height, and divided by 2. And let's see some options of LaTeX. So for example, if I write text color, and now with this kind of brackets I write brown, as you see, A has changed it. So instead of being black, now it's round. You can add colors or another things to LaTeX. In the links I send you in the PDF, and you can find all the commands necessary for doing these kind of things. So now I do the same. I copy the text color, and instead of round, I will say that the base, I want it to be blue. And now C has changed it and it's blue, and the same with H. We will write green. So now you see that it's easy to the user to understand that this is the base and this is the height, just because if we go to the triangle, it's easier. It's the same as we did with the slider. Let's write the dynamic values of C and H. I go again to the fraction, and here I select the segment A, that is the base, multiplied per I, which is the height. And I will do the same, the text color. I will copy this one for C, and the other one for the green, for the base, the green one for the base. So now look in the preview that only the number 1 is in green. We have to know the syntaxes of the numbers, or so the syntaxes of the command, sorry. So now if I close the following object with these kind of brackets, the whole number will be in green. And finally, it's equal to the value of the area of the triangle, that poly 1 gives us this number. So poly 1. And I write it again in brown. Copy the command and paste it here. And again the brackets for the full object. So here we have our text. We can change the size of this text. Going to the properties of the object. Here in text, we will make it medium size. And note that now if I scroll down or up, the text changes as well. For fixing it in the screen, I just have to mark this option, and now it will be fixed in the screen. Let's going to use the last tool from this Geogebra construction, that it will be the checkbox. So I will define a checkbox that I want that it shows or hides all the auxiliary lines. So I call it construction, for example, and here in this list I have to select all the objects that I needed for building this triangle. So let's select all the objects that are invisible here in the algebra view, which are the ones that are not necessary. So once I have selected all, I click on apply, and as you see, here I have my text box that when it's on, it shows all the auxiliary lines, and when it's off, it hides them. What is coming up now, it's maybe the most difficult part of this tutorial. So I want to make a text that when the age is 0, it's equal to 0, I will change the value of the slider, when the minimum value is 0. Now, and it's impossible to make a triangle, to construct a triangle without height. So I want that when h is 0, that here appears a text saying that it's a wrong construction. So let's do that. I will create first the text saying wrong construction. Here it is. And now I want to say that when the area of the triangle is equal to 0, so when poly 1 is equal to 0, that this text appears and this one hides. So let's do this. So here in advanced, and in the condition to show the object, when poly 1 is equal to 0, then it will show you the object. It will show only the object when poly 1 is equal to 0. And remember that you have a manual where you can check all these condition sentences. So for example, for saying that it's equal, I have to write 2 equals. So now it's 0, so it appears, but when it's different from 0, this text disappears. I will do the same with this area, with this text. So now in here in advanced, when poly 1 it's different from 0, for writing difference I have to do, and I have to do it like this, it's equal from 0, then show the object. So now it's equal to 0, h is equal to 0, so the area of this triangle is equal to 0, then this text of the formula does not appear, but when it changes appears. So now here you see the difference. I will make the letters bigger, for example like this, and put it on here, so that automatically appears when the area is 0. Now that I have constructed all the worksheet, and I will make it nice. For example, the value of the slider h, I can make it half, and like this. Instead of the width it's 200, I can say it's 100, because the maximum value it's the half of the other slider. So now it's more easier for the user to know that this value is the half. Here it's 9, and here it's the half, 4.5. We make sure that everything works. Remember as well to use this property for the other text. So now everything stays. This the absolute position on screen, what it basically does is that, and when you scroll up or down with the mouse, the text does not move. And finally, I will hide this window, the algebra window, and try to make the axis disappear. So I make a click with the right button of the mouse and click here on axis, and finally it disappears. And here we have our nice worksheet. It's important to check at the end of of the construction that all is working. So for example, go step by step and try to find if you have any mistake. Now if I go here to this text, to the formula, here I see that I forgot to put a 2 instead of the value b. So this is very important because you can lose some points making this kind of mistake. So this, for that reason, it's very important to go at the end of the construction and make this last check. So now it is definitely working, and here you can get all the points.